In this video, we're going to use representative sampling to help us make a decision about a population. A caterer is planning an event for 800 guests. Before the event, the caterer asks a random sample of 50 guests what type of meal they would prefer. The table shows the results. So these are the 50 guests. Out of the 50 guests, 23 said they'd prefer chicken, 7 said fish, 14 said vegetarian, and 6 said vegan. Now, assuming that these sampled guests are representative of the population, how many of each meal should the caterer arrange? We know he should arrange a total of 800 meals. But the question is, how many of each type? Obviously, if he does something like 800 chicken meals, that's fine for the people who want chicken, but it's going to disappoint all the people who wanted a fish, vegetarian or vegan meal. So what do we do? There are a few ways of thinking about this. One way is to use proportional reasoning. Let's start with chicken. If 23 out of 50 in the sample wanted chicken, how many people out of the whole population of 800 would want chicken? Now, that's a bit complicated, so how about we ask a simpler question? How many people would want it if we had a sample of 100? Well, we can't know for sure, but we can estimate that because 100 is twice as much as 50, we'd expect twice as many as 23 people to want it. So that's 46 out of 100 who would want chicken. And then we could ask how many out of 800 would want chicken. Remember, this is what we're looking for. How many would want each type of meal out of the total population of 800 guests? Well, 800 is 8 lots of 100. So we would expect 8 times as many as 46 to want chicken out of 800. 46 times 8 is 368. So here's our answer. It's 368. Let's just check this looks sensible. There was a sample of 50 and 23 is just a bit less than half of that. So if the sample is representative of the whole population, which is what we're assuming, then we would expect just under half of the 800 guests to want chicken. And 368 is a little bit less than half of 800. Half of 800 is, of course, 400. So the caterer should arrange 368 chicken meals. Let's move on to fish. We can see that 7 out of 50 want fish. That means 14 out of 100 would want fish, and multiplying by 8 we can see that 112 out of 800 would want fish. So that's 112 fish meals, which I'll write down here. Now we can do the same kind of method to find the total number of vegetarian meals and vegan meals that the caterer needs to arrange, but I'm going to show you a different method. So, using the previous method, we would have started with 14 out of 50 and tried to scale that up to something out of 800. But another way of looking at it would be to think 14 50ths of the sample wanted vegetarian. So 14 50ths of the sample wanted vegetarian. If we assume that the sample is representative, then we can say 14 50ths of the total population of 800 would want vegetarian. So we need to work out 14 50ths of 800. And that's the same as working out 14 50ths multiplied by 800. And doing that gives us an answer of 224. So the caterer should arrange 224 vegetarian meals. Now, it's worth noticing here that in the sample of 50, we had twice as many people choosing vegetarian meals as fish meals. 14 is twice as much as 7. And if the sample is representative of the population, we would expect twice as many people in the population to choose vegetarian as fish. And hopefully you can see that 224 is twice as much as 112. If you spotted that, you could have avoided doing this working and just doubled 112 to get 224 here. Finally, let's have a look at how many vegan meals the caterer should arrange. 6/50ths of the sample wanted a vegan meal, so we would expect 6/50ths of the population to want a vegan meal. So to calculate that, we just need to do 6/50ths multiplied by 800. And that gives us 96. So we need 96 vegan meals. And this is our final answer. A good thing to do at this point is to check that 368 plus 112 plus 224 plus 96 equals 800, because remember, we're planning 800 meals in total. If these don't add up to 800, then we know we made a mistake. But like I said, if you check, you'll find that these add up to 800. So we know we've got this correct.